Our biggest goal when we're thinking about how we want to find the best estimator for our parameter is that we want to begin by reducing or minimizing the amount of error that we have, or the difference between our prediction and what we actually observe, right? This is going to be the difference between our best guess, that line, and whatever we observe. And that's calculated or expressed as yi minus y hat. Or what we know y hat to equal is alpha hat minus beta hat times x. So we can essentially see, right, the distance from our yi and that regression line. If we look back at our example from before, you can see that we're going to go and calculate our residuals or our errors as the distance then between the prediction, which is expressed by these red dots, and then each residual is going to be the distance from that prediction and the actual observation that we observed. Now, this gets a little tricky if we start thinking about, we want the best line to reduce the greatest error. So if we wanted just to take the sum of all of these deviations, right, I think that's a pretty natural starting point, but that's actually not a really great criterion. And I want you to think a little carefully before I move on about why that would be. And this is because all of the errors essentially are going to equal out, right? If you have one that's above the line and one that's below the line, those are going to cancel each other out if we're taking the sum. So really, we can see here that there are quite large discrepancies, but the line is actually doing a pretty good job in the sense of minimizing the summed deviations. What we're more interested in, and I don't want to get too deep into the actual calculus behind this, but we're going to say that the best line is going to be the one that reduces the sum of squared error. And again, we're going to get into what this means, but we're defining this right now as the most efficient, unbiased estimator. That is our definition of why it is best. So again, like for right now, just trust me. But what's going on in the background is that we are going to essentially minimize, using calculus, this equation, the sum of squared errors, with respect to our alpha and our beta. So if you're interested, you can go check that out, but I'm going to do that by kind of waving my hands, and essentially these estimates are going to be our best guess as to what the true parameters are. Now, after we've done all of our nice calculus, we get these equations for, again, minimizing the squared sum of errors. And both of these functions, or sorry, both of these estimators are going to be functions of the data. So going back to our presidential election data, we know, right, that our estimate for alpha was 39.3, and our estimate for the beta, or the relationship between x and y, was 0.75. Now, how do we actually go about interpreting these estimates?